In this video, we are going to talk about comparing and ordering rational numbers, so fractions and decimals. Okay, so ordering decimals, I always think of it kind of like putting words in alphabetical order. You know, if you're comparing animal and apple, the A's match, so you go to the next letter. And you know, N and animal comes before P and apple, so the word animal comes before apple. It's the same deal with decimals. If the first number matches, go to the next number. If that matches, go to the next one until you find one that doesn't, and then just figure out which one comes first. Okay, so on the first one here, I want to order this list from least to greatest, smallest to biggest. What I would recommend doing is extending your numbers so that they all have the same number of decimal places. I usually start with 3, and then if I discover I need more, I can always go back and add more. So for the first one, I'm just going to write down below the 5.214. It already has 3 decimal places. I'm just going to rewrite it like it is. 5.2 repeating would really be 5.2 and then as many 2's as I want to write. Right now, I'm making each of them have 3 decimal places. 5.21 is a terminating decimal. If you watch the last video about converting between fractions and decimals, we talked about how terminating means it stops. So if I want to extend a terminating decimal, I can do that by adding zeros, however many zeros I want. In this case, I just need one of them so that I've got my 3 digits on each. They each have a 5 before the decimal, so that doesn't help me. So I go to the next one. 2, 2, and 2, those match, so that doesn't help me. The next one is a 1, a 2, and a 1. Well, I know 2 is bigger than 1, so I know my biggest number in this list is this one right here. So I'm going to go ahead and write down 5.2 repeating as the biggest. Now, when you write your answers in order, don't write what you changed them to. So don't write the extended version. Or if you've got fractions, don't write the decimal conversion. Write the original number that you were given. So 5.2 repeating. Now, on the other two, they both went from 2 to 1. So I need to move on to the third digit. I'm comparing a 4 with a 0. 0 would be smaller. So the one that comes first in this whole list is the 5.21. Then it would be the 5.214. And then we had already determined that the 5.2 repeating was the biggest. So there's my numbers in order from smallest to biggest, least to greatest. On the next one, I'm going to do the same kind of deal, but it's important to remember that negatives go backwards. As I accidentally crossed the word out instead of underlining it. Negatives, if you watched any of those videos or if you were in my class, I talk a lot about thinking of negative numbers like money. What's worse for your bank account? What's best for your bank account? So that's what we're going to do on this. I'm going to extend them first. So negative 0 point, it's going to be a whole bunch of 6, 4, 6, 4, 6, 4s. Like I said, I usually start with 3 decimal places, and then if I need to make them bigger, I can. So just for now, I'm going to put 6, 4, 6. And I know if you look ahead at the other numbers, I could have just left it as a 6, 4, and it would have allowed me to compare. But I just want you to kind of get in the habit of knowing how to extend if you need to. The negative 0.6, now that's terminating decimal, it stops. So to make it bigger, I can add zeros. And negative 0.68, again, if I need to make it bigger, I can add zeros because that's a terminating decimal. So I'm going to start at the first number. If that matches, I'm going to go to the next. They all start with 6's, so that gets me nowhere. Then it's a 4, a 0, and an 8. Now, I know usually the 0 would be the smallest, but remember these are negatives. So what's worse for your money? What's best for your money? Being in the whole 8 is worse than being in the whole 4 or 0. So negative 0.68 is my smallest. Then it would be the negative 0.64 repeating. And then the negative 0.6 is actually the best one here. It would be the biggest. On my number line, it would be furthest to the right. So there's my numbers in order from smallest to biggest. If you're comparing values that are in different forms, unless they're ones that you just already know the values of really well, I would recommend changing them all to decimals. Usually that's going to be a lot faster than making them all fractions or making them all percents. And I know in my classes, based on our pacing guide, we haven't even gotten to percents yet. So I'm just going to make everything decimals. 3/4, you might already know, or if not, take top divided by bottom. That's the same thing as 0.75. To change a percent to a decimal, I'm going to scoot 2 times to the left. If you don't see a decimal point already in it, then it's hiding at the end. And I'm going to scoot away from the percent sign because I'm wanting to get rid of it. So 70% is the same thing as 0.7 or 0.70. And 0.7 repeating, it would be sevens over and over and over. So if I want to extend it, I can put 7, 7. If I had needed to, I could have extended these all to 2, 3, 4, 5 decimal places, whatever it takes. So as I compare them, they all start with sevens. That gets me nowhere. And then it goes to 5, 0, and 7. The smallest one there would be the 0. So the smallest number in this list is the 70%. And then 5 is smaller than 7. So 3/4 is next. Remember, use the original form that the numbers were given to you in. And then 0.7 would be the largest. Again, same thing here. Negatives count backwards. So once we convert them, we're going to think about it like money. What's worse for your bank account? What's best for your bank account? This one, I must have erased, and I accidentally erased part of my percent sign. I'm on a roll today, folks. So negative 68%. To change it to a decimal, I'm going to take my invisible decimal point and I'm going to scoot to the left. So that's going to become negative 0.68. The next one, take 3 divided by 5. You get negative 0.6. I can make that bigger by putting a 0. And this one, negative 0.7. I can make it bigger by adding a 0 if I need to. So I'm going to look at the first digit. 6, 6, and 7. Well, the 7's different. Ordinarily, that would be bigger. But because these are negatives and I'm counting backwards, 7 is worse for my money. It's more in the hole. It's further to the left on a number line. So negative 0.7 is the smallest. And let's think of it like money. Being in the hole 68 cents is worse than being in the hole 60 cents. It's further to the left. So the next smallest is negative 68%. And then my negative 3/5. If you're comparing two fractions, there's a couple ways you can do these. You can change them to decimals, or you can find common denominators, or there's a shortcut. I'm going to show you all 3 ways. They all work perfectly fine. You use the way that makes the most sense to you. So the first option is to make them decimals. So with 3/4, I'm going to take 3 divided by 4, or it might be one you know. That's going to give me 0.75. For 5/6, I'm going to, in my calculator, take 5 divided by 6, and I get 0.83 repeating. So when I compare these, 7 is smaller than 8. So that means 3/4 is smaller than 5/6. If you want to get common denominators, you've done that before in previous years. You would have done it in 6th grade. We have not done that yet this year. It's coming in the next section in this chapter. But what I'm going to do is look at the 4 and the 6. I want to find a number that they both go into. I know 4 and 6 will both go into 12. Or I know 4 and 6 will both go into 24. Pick anything that they both go into, and I'm going to rewrite the fractions with that number on the bottom. So I know they go into 12. I'm going to use 12. To get from 4 to 12, I have to multiply by 3. So also take the top number times 3. 3/4 is equivalent to 9/12. In other words, 9/12 reduces to 3/4. To get from 6 to 12, I'm going to multiply by 2. So then I also take the 5 times 2 and I get 10. 5/6 and 10/12 are equivalent. 9 out of 12 is less than 10 out of 12. So again, it gives me that less than sign. The third way is the shortcut. This is my favorite way, but like I said, pick the way that makes the most sense to you, that you think looks the fastest and the easiest. You're going to get to the same answer as me, so why would I care how you get there as long as you get there? Here's my shortcut. I have 3/4. I have 5/6. I'm going to multiply on diagonals, but you have to remember to multiply up on the diagonals. So I'm going to multiply up. 6 times 3 is 18, and I'm going to make a note of that right here. I'm going to multiply up. 4 times 5 is 20. I'm going to make a note of that there. I got a smaller answer on the left side, so the fraction on the left side is the smaller one. So all three methods lead me to the same answer. 3/4 is less than 5/6. Let's do some more of those. 3/8 and 5/12. Again, on this one, I'll show you all three ways. Past that, I'm going to stick with the shortcut, but you can continue to do whatever you like the best. So if I'm going to do decimals, I'm going to take 3 divided by 8, and I'm going to get 0.375. 5/12, I'm going to take 5 divided by 12, and I get 0.416 repeating. 0.3 something is smaller than 0.4 something, so the one on the left, again in this problem, is the smaller one. If I want to get common denominators, I know that they both go into 24. Or 8 times 12 is 96. You could use 96. That's fine. You could use 48. Anything that they both go into is going to work. So I'm going to write them both over 24. To get from 8 to 24, I multiply by 3. So also take 3 times 3 and I get 9. To get from 12 to 24, I multiply by 2. So also take 5 times 2 and I get 10. 9 is less than 10, so that's my smaller one. The shortcut. I'm going to multiply up on the diagonals. It's important that you remember to multiply up. I'm going to take 12 times 3 and get 36 and make a note of that up here. I'm going to take 8 times 5 and get 40 and make a note of that up here. I got a smaller answer on the left side, so the fraction on the left side is the smaller one. Now, when they're mixed numbers, don't stress, because either the number in front of the fraction matches and you can ignore it as you compare them, or one of them's bigger than the other and you don't have to do anything with fractions. On this, they're both starting with 2, so I'm not even going to worry about the 2. I'm just going to focus on the 1/4 and the 11/50ths. I'm going to continue, like I said, with the shortcut. 50 times 1 is 50. 4 times 11 is 44. I got a bigger answer on the left, so the fraction on the left was the bigger one. Be careful when they're negatives, because the one that looks bigger is actually the one that's smaller. I know I say this a lot, but I still think if you think about money for negatives, it makes it a lot easier to kind of visualize. So I'm going to multiply up. 8 times 14 is 112, but remember I need to put a negative sign, so negative 112. And then I'm going to do 15 times 7, and I get 105, but that needs to be a negative 105. Negative 105, even though I don't want to be in the hole in my bank account $105, that's better than being in the hole $112. So this one is actually the bigger one on the right. The last problem here, please don't overthink this. I don't even need to worry about those fractions because just look at the numbers in front of them. -5 is further in the hole than -2. -2 is bigger. So who cares what fraction goes with it? You can compare them just with the numbers before them. Okay, that is the end of this lesson. So I know I say this every time too, but there's your information if you need more help and you want to check out my YouTube channel, Math with Luger. If you need my classroom updates, my classroom Facebook is Luger's Math Class, or email me there at ajl4@vigoschools.org, or put a comment here on the video. I'll try to help you out the best that I can. So hopefully that helped you, and I hope you'll check out another one later. Thanks. Bye.